Jai Shri Krishna, guys. Hello, friends. Welcome back to my channel. And today we have taken a question from Wave Optics chapter. Then the question comes from the topic polarization, which is covered in Wave Optics chapter. Wave Optics has a huge spectrum of different subtopics. One of the subtopics is polarization. According to the examination point of view, polarization is a important chapter. Many great competitive exams like JEE Mains, JEE Advanced, and other international and national physics Olympiads ask questions on polarization. It has been seen as a trend in past few years, and this is one of the conceptual questions. So before going through the question, I would like to tell you that do subscribe the channel as you will be getting great physics content over here, and I will be posting a whole lot of awesome questions and great physics related information on my channel. Okay, so the question reads: a beam of plain polarized light falls normally on a polarizer. The cross section of the polarizer is given as 3 into 10 to the power minus 4 meter square. So the polarizer on a polarizer which rotates about the axis of the rays with an angular velocity of 31.4 radians per second. So we are also given the angular velocity as 31.4 radians per second. Find the energy. So we need to find the energy of the light passing through the polarizer per revolution and the intensity of the emergent beam if the flux of energy of the incident ray is 10 to the power minus 4 watts. So in the first part we need to find the energy, and in the second part we need to find the intensity of the emergent beam. We are given the energy of the incident ray as 10 to the power minus 4. So I must say you must pause the video over here and try doing the question over here, and then move on to the explanation part. This will increase your chance of learning. So coming to the explanation part, first in the first part of the explanation we will find the requirements to find the energy and the intensity in the format asked in the question. So so on seeing the solution, if I naught is the intensity of the plane polarized light incident on the polarizer, then the intensity of the emerging light is given by I equals to I naught cos square theta. Okay, so on considering I naught as the intensity of the plane polarized light, we know the formula for intensity of the emerging light as I equals to I naught cos square theta, which is emerging from the other side of the polarizer. This is a very basic formula you all must be knowing. So calculating the average value of intensity over one revolution can be calculated as the polarizer is moving through an angular velocity of 31.4 radians per second, the average intensity over one revolution, we are finding the general equation for that. So I average is written as 1 upon 2 pi integration I d theta 0 to 2 pi, and further substituting the I with I naught cos square theta, we get I average equals to 1 upon 2 pi integration 0 to 2 pi I naught cos square theta d theta. So this comes out to be I average equals to I naught by 2. This is also a general equation which maybe you must not be knowing, but in many questions this is used. In many questions the same procedure is followed to find the average value of I. And now considering the second part of the explanation, we will find the intensity. So the intensity is given by power upon area. Yeah, it is a very basic equation that is being used in the question. Power equals to intensity times of area, and substituting the values. Substituting the values, we get I naught equals to 10 to the power minus 3 upon 3 into 10 to the power minus 4. The power is given in the question, and the area is also given in the question, which comes out to be 10 by 3 watts per meter square. And I average, which we had calculated in the first part of the explanation, comes out to be 5/3 watts per meter square on substituting the values. So the energy of the light passing through the polarizer per revolution will become energy equals to average intensity into area into time. Understand the equation very carefully. Energy will become intensity average intensity into area into time. Average intensity into area into time. Time can be written as 2 pi by omega. We know the general equation 2 pi equals to omega t. So the energy will become 5/3 into 3 into 10 to the power minus 4 into 2 pi by 31.4. These all values can be substituted from the given data and the calculated data. On solving, we get the energy of the light as 10 to the power minus 4. So the first part of the finding, we have found over here the intensity as 5/3, and in the second part we have found the energy as 10 to the power minus 4 joules. So basically it was a great question, and in this it was a great and easy question, basically easy question, but there was a little application of concepts, as one had to remember three different one had to use three different formulas: I equals to I naught cos square theta, intensity one and energy one. So guys, that's all for the question, and thanks for watching with this video. Today you have learned a topics, important topics question, and stay tuned on, yeah, I must say, stay tuned on this channel. Many great things are coming soon. I will be active from now onwards on this channel, as I was a bit active in my college schedule. So do like, share and subscribe the video channel, so that great content will also reach till you, and click the bell notification. Okay, so that's all for the for today. Okay, bye.